Hello students, this is Miss Cave, and today we are learning about how to find the area or the perimeter of a composite figure. So you've been given this note sheet in class, and so we are going to go ahead and fold it. So the top with the title and the vocabulary we'll put underneath, we'll fold like so. And then the bottom with our examples, we're going to fold up like this. And so today we're going to focus primarily on the area of composite figures, but we're also going to do activities in class that involve finding the perimeter of composite figures. And this is Virginia SOL 8.10. And this is the 2016 standards. So this is, these are examples of how we can find the area of composite figures. In class, we've already explored how to do this by trying to find out how long it would take a young man named Billy to mow his grass. And students were given a picture of the lawn and some information about the lawn and its dimensions, as well as how long it would take to mow a strip of that grass in order to find that answer. So from there, now we're going to go ahead and look at actual pencil examples that we may see for solving the area of composite figures. So we're going to pull up the flip here, the little flippy thing, paper. To find the area of a composite figure, what do we do? So that's what we did with the mowing problem. So what do we do to find the area of a composite figure? I'm asking my Extended Math 7 Core 2 class to give me a response. How do we find the area of a composite figure? How did we find the area of Billy's lawn? Ryan? By dividing an irregular shape into known shapes, we can then find the area of those known shapes and add them together. Okay? So to find the area of a composite figure, we subdivide the shape into shapes we know, or known shapes. Then we add or subtract. We'll talk later about why we would subtract the areas. So that's basically how we do it. We look at a shape, we think about the shapes that we know, and then we find those formulas. We use those formulas to find the area. So in order to do that, we're going to look at our area formulas, so you guys will have these that you can use. And I'm also going to give you the perimeter formulas for these because we will be using these for area. And I'm just going to add perimeter here because you need both of them. Okay, so for the square, the area of a square is equal to side squared. The perimeter we're going to use with big P. The perimeter of a square is 4 times the side length. We're just reviewing those formulas you guys have been using for probably several years now. The area of a rectangle, we use the length and the width. The area of the rectangle is found by multiplying the length times the width. And the perimeter of a rectangle is found by multiplying 2 times the length plus 2 times the width to get those 4 side lengths. You may also see the perimeter formula by, you could add those length and width together and then multiply by 2. So you may also see it 2 parentheses length plus width. It's the same thing. You'll get the same answer. Another known formula would be the parallelogram. The parallelogram, the area is found by multiplying the base times the height. The area is equal to base times height. And the perimeter would be all the side lengths. Just add the side lengths. would be, it wouldn't be, it would be this here, which we don't have a name for. It's actually a slant, but we're just going to add sides. We're just going to write add sides. Because the height is actually the distance between the base and the top of the parallelogram, and it forms a right angle. This is really important because this here is not your height. The height is not that slanted measure. Your height is what's given how tall the shape is. It connects the base with the top of the parallelogram. A triangle, the area of a triangle, you guys had to use this in the mowing problem, is we have base times height again, but this time it's 1/2 base times height. Because a triangle is half of a quadrilateral. And the perimeter, you're just going to add the sides. Whatever the sides are, you're going to add all 3 sides. For a trapezoid, we use this formula for Billy's lawn. And it was 1/2 height times B1, not squared or to the first power. It's just the first base plus the second base. These formulas will be given to you on a formula sheet I will be giving you guys that you can keep. You may use that on any test. You may use it on the SOL test. So you are not required to memorize these formulas. So you will always be able to use them. For now, you'll be using your note sheet. When you guys take your test, I'll give you a formula sheet that you can use. Yes?
What was the, because I thought when you had like exponents
It's not an exponent. It's the 2 bases. A trapezoid has 2 bases. This is a base, and this is a base. It has 2 bases. It's a subscript. It's not an exponent. It's just saying I have 2 of the same type of things. Because if you turned this trapezoid this way, now the base would be here. So it has 2 actual bases. And they're different lengths. With a trapezoid, the lengths are different. So what you do is this half ends up averaging the 2 bases. That's how the formula is devised. You have 2 bases. You have to include them both in your formula. And you multiply that by your height. And again, just like with the triangle, your height is the distance between the bottom of the trapezoid to the top. And the perimeter would be at all sides. Because they're going to be different depending on the type of trapezoid it is. At all 4 sides. Okay, and that brings us to our circle. So we have an area of a circle. Our area is, well, the first thing we want to do is we want to go ahead and label our circle. The distance all the way across is our diameter. The distance halfway across is our radius. And we will say that R equals radius and D equals diameter. These are important terms that you need to know, that you've learned before. The radius is the short one, it's only half, and the diameter goes all the way across. So to find the area of the circle, it's pi r squared. And to find the perimeter, we don't say perimeter of a circle. Does anybody know the word that we use for the perimeter of a circle? Circumference, yes. So we use a C for circumference. We have 2 formulas for circumference. We have one that when we have the radius and one when we have the diameter. If we have the diameter, it's pi times diameter. If we have the radius, it's 2 pi times the radius. So that way, no matter which is given, you can take that number and plug it into the formula. Both of these are your formulas for circumference. Any questions about any of these formulas? The one you may not have used very often is the trapezoid. You're probably most familiar with the square, the rectangle, triangle, and circle. Parallelogram, you should have seen that as well. The important thing with parallelogram, again, is to make sure that when you're finding the area, you're multiplying the base times the height, not the base times this side length that's slanted. Think of height as being up and down. which is perpendicular with the floor. Okay? All right, so now we have a few examples. So we're going to look at how we're going to solve these examples. So I'm going to pull this up. We're going to start. I'm going to cut these out. Notice I've given you a lot of room for these examples because they do take a lot of room. When you guys are doing these on your own, you're probably going to have to use separate sheets of paper, not for the notes, but for the worksheets that I give you because they do take a lot more space. So for example 1, it says to draw dashed lines to show the separation of the smaller familiar figures. So this looks like an ice cream cone, but I don't have a formula for that. So what I'm going to do is I'm going to draw dashed lines to show the separation. So what shapes do you see here? You see, Ruby June, what do you see? Okay, so she sees a triangle, and Ryan, what did you say you saw? Okay, so I see a triangle here, and I see a semicircle, which is a half circle. And it's asking me to find the area of this shape. So to find the area, now what I'm going to do is I'm going to take my two shapes, and I've got some room at the bottom, and I'm going to find the area of those two shapes. I'm going to start with the circle. I'm going to draw it here. I'm going to draw a picture of that circle there. What do I know about the semicircle? I know that the what is 5? The radius. So I have the radius equals 5 inches. Okay, so I have my circle. And then we're going to draw our triangle. What do I know about the triangle? I know the height is 8. So this is 8 inches. But remember, for a triangle, I not only need the height, but I need the base. What would the base of this triangle be? 10. And I know that because if you look at the picture, it's 5 is the radius of the circle, which is connected to the triangle. So all of the way across would be 10. So that would be 10 inches. Okay? Any questions as to how I found those numbers? Okay. So now I'm going to apply the formulas, and I do insist that you write the formulas when you go through this. So for the semicircle, area equals pi r squared. But because it's a semicircle, I'm going to go ahead and put this in my formula now so I don't forget. What am I going to do with that number once it's calculated? Because it's a semicircle, what do I have to do with this when I'm done? Allison? You have to divide it by 2. I'm telling you, if you wait till the end to divide by 2, you may forget. If you do it then, that's fine. If you do wait till the end. But I like to put it here because I can tell you I've made a mistake plenty of times by, oh, okay, I'm done. I got the answer. And then I forget to divide it by 2 and I get it wrong. So now I'm going to put in the numbers that I know. I'm going to use 3.14 for pi. And my radius is 5. And I'm going to divide it by 2. Now, ladies, you can use your calculators. You don't have to show me step by step like with the order of operations. You can actually take your calculators and you can start with 3.14. Oops, not 3.4. 3.14 times 5 squared. Okay? And then divide by 2 and press equals. So all I did was use my calculator and I applied that. And I got an answer of 39.25. Did anybody get a different answer? So see, that's all I did was I plugged that in. And I'm going to go ahead and make this a little bigger now. So I got 39.25 inches squared. And is that my final answer? No, that's just my semicircle. So I've done this part. Now I'm going to find the area of this triangle. And to find the area of a triangle, remember it's 1/2 base times height. So I'm just going to plug in what I know. 1/2. You can use 0.5, whatever. That's fine. 0.5 times base, which is 10, times height, which is 8. I'm just going to put all that in my calculator. 1/2 of 10 times 8 is what? 40. So this is 40 inches squared. So now I have my semicircle, which is 39.25, and my triangle, which is 40 inches squared. And what am I going to do with those two numbers? Okay, so the total area is going to be equal to that semicircle, 39.25, plus 40. And if I add those together, what do I get? 79.25 inches squared. Okay? Make sense? It's just taking it one step at a time. You subdivide the shape, redraw the shapes, or at least draw the formulas, write the formulas, and then you add everything together. All right, let's look at example 2. Now, again, we're going to do the same thing. It says, draw dashed lines to show the separation of the smaller familiar figures, then find the area of the figure. Okay, so what do you guys see here? JD? Okay, this triangle here. Okay, and a trapezoid. Okay, so you've got this triangle up here, you've got this rectangle in the middle, and then you've got a trapezoid. So you've got 3 shapes. So I'm going to start with my triangle. I know that the base of the triangle is what? 15. What is the height? What's the height of this triangle? 6. So the area of my triangle is 1/2 times 15 times 6. So this area is going to be what? I'm thinking 1/2 of 6, which is 3, right? Commutative property of multiplication says I can switch the numbers around. 1/2 of 6 is 3, and 3 times 15 is what? 45. Do I have to divide that or anything? No, it's a whole triangle. So, and I'm going to go ahead and put it on my shape too. That helps me. I'm going to put in my areas right on top of my shapes. And then that's my triangle. So next, let's move on to our rectangle. Rectangle's super easy. Do I know the length of my rectangle? What is it? The length? 15. Do I know the width? 4. So area is length times width. So area is 4 times 15, so it's 60 centimeters squared. So I'm going to go ahead and draw it on my shape, 60 centimeters squared. Now the last shape's a bit of a pain. The trapezoid's a little more involved, but again, we have everything that we need to solve it. We have a formula, we're just plugging in numbers and solving. So for our trapezoid, we need the bases and we need the heights, because the area is 1/2 times height, base 1 plus base 2. So do we know the distance across the bottom, which would be our base 1? 18. Do we know the height of our trapezoid? It gives it to us right here, 4. And do we know the area of the second base? What do you think? It's 15. You see right here, this distance here across lines up with this, so that's 15. So what I'm going to simply do is I'm going to plug everything in. 1/2 times my height, which is 4, multiplied by the sum of my bases, 18 plus 15. Now on your calculator, you have parentheses. We have the calculator as a tool. I say use it. I would put all of that in, but do not press equal until you're done. So let me show you. So over here on my calculator, I'm going to move this over a little bit. And I'm just going to put in, 5/10 for 1/2 times 4, okay? And then watch this, times parentheses 18 plus 15, and then the right parentheses, and then I'm going to press equal, and then I have my answer. Now you could do this step by step if you wanted to. You could just add what's in parentheses and then do your multiplication if the calculator confuses you. But the calculator, I mean, it's pretty simple for this one. You just have to make sure that you put your parentheses in so that you find the sum of those two numbers, those two bases, before you multiply by 4. And so my answer would be 66 square centimeters. And so, running out of room, but I'm going to maybe put it in over here. So how do I get my total? I add them. So I'm going to add 45 centimeters squared plus 60 centimeters squared plus 66 centimeters squared. And then my total is what? 171 centimeters squared. And again, I started out with an irregular shape. I subdivided it into the 3 shapes that I know. And then I found the areas. I do want you guys to follow these steps. I do want you to write down the formulas. I do want you to show me what you're plugging into the formulas. You can use a calculator, but believe me, the more organized you are with your work, you're less likely you are to get it wrong. And I'm not going to give you like 20 problems at a time, so don't worry. I'll give you a few at a time so you can practice this. All right, let's look at the last one. Example number 3. I'm going to fold my paper over a little bit. So now, what do we see? What do you guys see there? Julia? A weird-looking triangle, a scalene triangle. Okay, down here at the bottom. Is it a rectangle? I think it's a square. Oh, yes. It's just not drawn to scale. Yes. You see that it's 13 here and 7? It doesn't look like that's 13 and 7, but according to this problem, it is. Okay. So now we're going to go ahead and apply our formulas. So we're going to go down here. And I'm going to draw my irregular looking triangle. And I know my base is 7, and my height is what? 3. The area of a triangle is 1/2 base times height. So this is going to be 1/2 times 7 times 3. So the area of this triangle is 3.5 times 3, which is 10.5 square yards. So then I'm going to go ahead and put it in here, 10.5 yards squared. Next, I have this rectangle here. So I'm going to draw the rectangle, and it says it's 7 by 13. It doesn't look like it, but those are the dimensions that were given. So my area is length times width, which is 7 times 13. 7 times 13 is 91. So this is 91 square yards. So that rectangle in the middle is 91 square yards. Again, not drawn to scale. But we're going to follow our formulas and follow our dimensions that are given. And then the last piece is that parallelogram. And the parallelogram, we're given the base and the height, 7 by 3. So our area is base times height. Our area is 7 times 3, which is 21 yards squared. So we have our 3 shapes, and now we're going to simply add them all together. So I'm going to take those 3 numbers, I'm going to add them together, 10.5 for my triangle, 91 for my rectangle, and 21 for my parallelogram. If I add those 3 together, I get 122.5. Okay. So that is it for our guided examples. We will also be looking at these figures later and calculating their perimeters. But that is it for today's lesson. Please pause the video.